All right, so today in Algebra 2, we're going to finish up our section 1.1 notes. So we stopped here at example number 4 yesterday, so we're going to pick up here. So example number 4, it says, for what intervals is f of x equals x squared minus 9 positive? For what intervals is it negative? Okay, so remember that we read a graph from left to right. Okay, so we're going to remember how we read a graph. Okay, positive means where it is above the x-axis. Okay, so positive is asking where is the graph above the x-axis. Negative means where is it below the x-axis. And then constant means where is it remaining the same value. So you will have like a constant or a horizontal value. Okay. All right. So let's look at this. We have a parabola, right? Because it's U-shaped. So it is positive. Okay. So above the x-axis, positive, positive. Okay. And again, intervals, we're looking at x values. So an interval is going to be x values that we put in. All right, so the smallest x value, okay, again, this is going from infinity. So we're starting at negative infinity. That is in parentheses. It stops being positive right here at -3. We don't call it either positive or negative at -3 because at -3 the y is 0 and that's neither positive or negative. So negative infinity to -3 parentheses because that is not included. Then it becomes positive again back over here at +3. So parentheses +3 up to, it goes on and on and on forever. It's going to continue being positive, and so positive infinity parentheses. So those are the intervals where my graph is positive. And again, remember, intervals, we're talking about the x values that we're putting in our interval. So now where is it negative? So where is it below the x-axis? So all of this is below the x-axis. So from -3 to 3, it's below the x-axis. But again, at -3, it's 0. At +3, it's 0. 0 is neither positive or negative. So negative is going to be -3 to 3, both in parentheses. Constant. Do we have any constant where we just have a horizontal line? No. So this is never constant. So we could write never, or we could do the none, the symbol, the 0 with the slash through it, which means never. All right, some more vocabulary that we're going to take care of. The greatest value of a function that a function attains is known as the maximum of the function. And we've talked about this before. The least value a function attains is the minimum of a function. And on a parabola, the maximum or the minimum is going to be at your vertex. The value, these are y values. Okay. On a parabola, it's the y value of our vertex will be your maximum or your minimum point. Okay. All right, so last page of notes. Example number 5. And again, we're reading the graph from left to right, just like we read a book. So example number 5. For what values of x is g of x equal 2 minus the absolute value of x increasing, decreasing? Okay. So now this is different than positive, negative. Okay. So increasing means where it is rising from left to right. So it is going up from left to right. Decreasing means where it is going down from left to right. Constant means where it is constant, horizontal. All right, so increasing. So from left to right. So my graph starts way down here. That's the furthest left. Okay, as I'm going to the right, my graph is going up. So this is increasing. It stops increasing at this point, and then it's going to turn, right? So again, I'm looking at my x values, and I'm going to put this in interval notation. It's starting way down here at negative infinity, so that's a parenthesis. It stops right up here, okay? My x value is 0, so that's 0. Okay. decreasing, decreasing. So now I start right here and it's going down, which means it's decreasing. The y values are getting smaller. So the x value where it starts to decrease is at 0. Where it stops decreasing, well, this graph is going to continuously decrease to infinity. Constant, I don't ever have any place on here, no horizontal lines, so again, constant is never. Okay. All right. And on when we're doing increasing, decreasing, and constant, we are always going to use parentheses here. So next, the average rate of change is the ratio. Okay, average rate of change. This is like slope. Remember we discussed the slope, y2 minus y1 over x2 minus x1. So when we talk about the average rate of change, we have a new formula, but it's really the exact same thing, y2 minus y1. But instead of calling it y2 minus y1, we call it f of b minus f of a, because we're talking about functions, okay, over b minus a. This is the same as the slope of the line segment between points a comma f of a and b comma f of b. So instead of saying x comma y, we're saying a comma f of a. Instead of over here saying like x2 y2, we have b f of b. So this is just f of a means the y value of the function when x is equal to a. So if we look over here, this is the point a f of a, this is the point b f of b. We want that slope of that line. So we want to know how far did we go up and over. Okay. All right, so down here, what do the average rate of change, what do the average rates of change over the intervals -2 to 0, 0 to 3, and -2 to 3 indicate? Okay, so we're going to start with this first one. So we have 3 different problems for each of these. So this first one, they tell me that the function is f of x equals 1. So this is the same thing as saying y equals 1. This is the horizontal line, y equals 1. So first, we're going to do the interval from -2 to 0. And remember, intervals, these are x values that they give to me, okay? So if I want f of x, okay, and again, it doesn't matter which one I start out with. So if I'm looking at f of -2 minus f of 0 over -2 minus 0, that's what I'm looking at. So f of -2, that means I go to my graph. When x is -2, what is my y value? My y value is 1. So this equals 1 minus f of 0. So this means when x is 0, what's my y value? X is 0, y is 1. So 1 minus 1 over -2 minus 0. So on top, 1 minus 1 is 0. On the bottom, -2 minus 0 is -2. So 0 divided by anything is 0. Next interval was from 0 to 3. Now this way, I will do, to show you that it doesn't matter, I'm going to do f of 3 minus f of 0 over 3 minus 0, because I can, it doesn't matter which one of these I start with, as long as whichever one I use first on top, I use the same first one on the bottom. So f of 3 means when x is 3, what is y? It's 1. When x is 0, what is y? 1 over 3 minus 0, which is 3. On top, 0 over 3, this also has a slope of 0. So then, the last interval on this one, between -2 and 3. So on top, I'm going to do f of 3 minus f of -2 over 3 minus -2. So again, on top, f of 3, when x is 3, what's y? 1. Minus f of -2, when x is -2, y is 1. Over 3 minus -2 turns to 3 plus 2, 5. 0 over 5 is 0. Okay. What do we notice? We notice that we had the exact same average rate of change each time of 0. So here we had the same rate of 0. Therefore, so my three little dots means therefore, this is a constant, right? It's a constant rate, okay? It's a horizontal line. So now we're going to do the same thing with this next one. So now we have g of x equals 1/2 x minus 1. They've graphed it. We see that this is the line. Our slope is 1/2. We have a y-intercept of -1. The slope of the entire line is 1/2, okay? We're looking for what is the slope over each of these intervals, okay? Well, we're expecting, since we know that the whole line has a slope of 1/2, we should expect that each of these intervals also has a slope of 1/2. But we're just going to check that. So again, from -2 to 0, if I do f of -2 minus f of 0 over -2 minus 0. So on this one, I look at when x is -2, what is my y value? My y value is -2. Minus f of 0, when x is 0, what's my y value? -1. Over -2 minus 0 is -2. So on top, -2 minus -1 turns to -2 plus 1. -1 over -2 is 1/2. That's what we thought we were going to get. So now the next interval, 0 to 3. So f of 3 minus f of 0 over 3 minus 0. So again, I look at my graph. When x is 3, it tells me my y value is 0.5, or 1/2. When x is 0, my y value is -1, over 3 minus 0 is 3. So on top, 1/2 minus the -1 turns to 1/2 plus 1, which is 1.5, right? Or 3/2, over 3. Remember, when I have a fraction divided by a fraction, I take the one on the bottom. This is really like 3 over 1. I flip and multiply. So multiply everything by 1/3. Those all cancel. 3 on top, 3 on bottom cancels, and I'm left with 1/2. Again, I got a slope of 1/2. It's what I expected. So the last one, we're going to go f of 3 minus f of -2 over 3 minus -2. So when f was 3, my y value was 1/2, or 0.5. When my x value was -2, my y value was -2. Over 3 minus -2 turns to +5. So on top, 1/2 plus 2 turns to 2.5, or 5/2, over 5. Again, flip and multiply. My 5's cancel, and I have 1/2. So here, again, I have a constant rate of 1/2. Therefore, I know that this is linear function, or it's a line. All right, our last one, we look at the graph, okay? Our graph is a parabola. H of x equals x squared. A parabola is going to, it doesn't have just one slope for the entire parabola like a line will, but we can find the rate of change or the slope over different intervals. So that's what we're going to look at here, okay? So again, we're going to do -2 to 0. So I'm going to do f of 0 minus f of -2 over 0 minus -2. And f of 0, so when x is 0, my y is 0. So I have 0 minus, when x is -2, my y is 4. So 0 minus 4 over -2. -4 divided by -2 turns to +2. So on this interval right here, my parabola has a slope of +2. That's what that's telling me. Now I'm going to go to the next interval, 0 to 3. So I'm going to do f of 3 minus f of 0 over 3 minus 0. So I'm going to come up here and I'm going to look at my graph. When x is 3, my y value is 9. So here I have 9 minus, when x is 0, y was 0. Over 3 minus 0 is 3. So I end up with, on top, 9 minus 0 is 9, divided by 3 is 3. So on the interval of 0 to 3 of this parabola, the slope of that part of my parabola is 3. So now we're going to look at our last interval from -2 to 3. So we're going to do, let me switch colors here. So let's get me a little bit more room. So I'm going to do f of 3 minus f of negative 2 over 3 minus negative 2. I know on the bottom 3 minus negative 2 turns to 5. So I'm going to look at my parabola. When x is 3, my y is still 9. Minus, now when x is negative 2, my y was 4. So on top, 9 minus 4 is 5. 5 divided by 5 is 1. So that tells me that from negative 2 to 3, this part of my parabola has an average rate of change or an average slope of a positive 1. Notice I did not get the same average rate of change each time on my parabola. I had a 2, a 3, and a 1. Okay, so here, no constant rate of change. What does that tell me? Therefore, I know this is not a linear function. Okay? All right, so that wraps up section 1.1. You will now be able to do all of the homework problems that were assigned yesterday. So finish up the homework that you started yesterday. That will be due tomorrow. And then remember, at the end of the week, we're taking a quiz over everything that we talked about yesterday and today.